so we are going to look at improper integrals, and what this means is either one of my limits will be infinity, so like it could go from a number to infinity, or negative infinity to a number, or negative infinity to infinity. So my domain is without bound on either one side or both, and then also the range, like if the area under the curve just continues to go on and on and on. Those are called improper integrals. All right, so here's the definition. If f is continuous on, then there's three options, so kind of what I just said. The interval and a is included, so the interval from a to infinity, then I write that as the integral from a to infinity. I'm integrating f of x dx on that interval. I can actually substitute for infinity b, and then look at the limit as b approaches infinity of my answer. So after I integrate from a to b, then I can evaluate the limit, right? Then number 2 says I'm going from negative infinity to b. Then when I set up my integral, it's going from negative infinity to b, f of x, and then I sub in a, then I'm going to evaluate whatever that answer is as a goes to infinity. Number 3 has 2 split ups. We're going to find a value in the middle of that function where we can split the function up and go from negative infinity to c, and then c to infinity, and then it splits up just like the top two, just like 1 and 2. The limit as b goes to infinity for the second one, and then a goes to infinity on the first one. A goes to infinity on the first one. Okay. It should be negative infinity on this one, and then this one would match this one. It would go to negative infinity. All right, so fix that on number 2. Make sure that's negative infinity. All right, so if my limit exists and I get a number, it's finite, not infinite, we say that integral converges and it has a limit. And the limit is the actual value of the integral. So that just means when I do this piece right here, this last evaluating, if I get a number there, then that limit value is the answer for the integral, and it converges. If the limit fails to exist, so like if I evaluate the limit and I get infinity or negative infinity, we say that the integral diverges. So diverging means it doesn't close in on a number. I can't find the area under the curve because it's not getting closer and closer to anything. All right. So here's an example and a graph, and you can graph it on your own. But we're looking at the natural log of x over x squared, and it goes from 0 to infinity. So what's the area under this curve? So the setup of this looks like integral. Okay, so I'm going from 1 to infinity for the natural log of, I already went the right limit, natural log of x over x squared dx. But I know from the definitions that I gave you just a minute ago that I can rewrite this. And I can rewrite this as going from 1 to b, the natural log of x over x squared dx. And then when I finish this, just noting this, when I finish this, I'm going to take the limit as b goes to infinity. I'm not going to write that all over there because we're going to integrate and it makes a big mess, but just keep in mind this is where we're headed to find the limit. All right, so let's go ahead and integrate this. So this looks to me like it's probably integration by parts, because if I try to use substitution, when I take the derivative, I'm going to get 1 over x instead of 1 over x squared. So I'm going to do integration by parts, and I'm going to let u equal the natural log of x. And that would make du 1 over x. And that makes dv 1 over x squared what's going on with my computer. And then v is going to be, when I integrate that, remember this is x to the negative 2. So that's going to be negative 2. So I have x to the negative, oh, I'm integrating, sorry. I'm going to integrate x to the negative 2, so I'm going to go up 1 on the power and divide by the new power. So that's 1 over x. Okay, all right, so now I can do my integration by parts. So remember, integration by parts is u times v minus the integral of v du. All right, so I have u times v, so the natural log of x times v 1 over x. And I'm going to evaluate that from, put brackets around this. This is going to be evaluated from 1 to b minus the integral of v du. So minus the integral from 1 to b of v, which is 1 over x du. Oh, sorry, yeah. dx. All right, there we go. Wait. Du is 1 over x. Why did I not write that? Okay. V du. There we go. All right. So now I can integrate this. So I'm going to go ahead and evaluate this. So I'm going to plug in b. So I have natural log of b times 1 over b. So I'm just going to put that b on the bottom. Minus the natural log of 1 times 1 over 1. All right, so that's just going to be 0, right? The natural log of 1 is 0, so that's out. Oh, I missed the negative sign here, sorry. Okay, so the natural log of 0 is 1, so we're done with that. All right, so that's evaluating that first one. Now I have to integrate this one. So this is really x to the negative 2. I've already integrated that. So this is going to be minus, we know this is 1 over x, and we're integrating that from 1 to b. All right. So I've already evaluated this. I'm going to leave this natural log of v over b. We know that one went to 0. And so now I have minus plugging in b, and then minus plugging in 1, but it's minus a negative, so plus 1. Okay, so now I'm looking at the limit of the area as b goes to negative infinity. So, positive infinity. So I'm back to this that I started. So remember, when I get this limit down here, or when I get this answer down here after I've integrated, I have to now, because I adjusted my limits of integration, I've got to look at the limit as b approaches infinity of this thing. Okay. So what happens to this as b goes to infinity? All right, well, oh, sorry, this is, why did I write x? Why do I keep doing that? I evaluated this at b. I don't know. I hope you caught that. All right, so now I'm going to plug in infinity. Well, I know as this fraction goes to, as I plug in infinity down here, this fraction is going to 0. This number is not affected because there's nothing to plug in, so that's just going to be 1. So what about the limit as b approaches infinity for negative natural log of b over b? Well, this is L'Hopital's rule. We have to use that. And remember L'Hopital's rule, because right now if I plug in infinity, I'm going to get infinity on the bottom, infinity on the top. So I have to or negative infinity on the top, but I have to do L'Hopital's rule, so I have to adjust this. So the limit as b approaches infinity. So I'm going to take the derivative of the top. So the derivative of top is 1 over b. Derivative of the bottom is 1. Okay, so now I know as b goes to infinity, as I plug in infinity, this thing's going to blow up, right? Which means this is going to 0, which means my whole fraction goes to 0. So now this went to 0. I had a 1 left up here. So I have 0 minus 0 plus 1, which is 1. All right, so that means the whole thing way back up here, that this, that this converges to 1. Okay, so that means as I look at this area under the curve, and we found it to b, and then we looked at the limit as b goes to infinity. So as I let that number, so as I keep going, this gets smaller and smaller and smaller until it doesn't really matter what I'm adding anymore. So it's converging to 1. That's the value of that area. Okay, so I'm going to talk about setup on a couple of other ones, and then, of course, we'll work some more when I see you again. So if I have something like negative, the integral, integral from negative infinity to infinity of 1 over 1 plus x squared. First of all, I know that that's tangent inverse from my tables, right? But this is one of those that I have to split up. So I'm going to choose a C to split this into pieces. And you can look at the graph if you want to and see how you want to split it. I like using 0. So I'm going to split this. All right, so now I can evaluate this limit. So I can do the first one. I have negative infinity to 0, I'm just going to split it. I'm going to go ahead and rewrite it. Sorry, it's going to make the video a little bit longer. So I'm going to rewrite this as the limit as a goes to negative infinity, integral of a to 0, 1 over 1 plus x squared dx. And then I'm going to wait on this. I'm going to do just like I did last time. And I'm going to wait on this. I'm going to evaluate this limit, and then I will, evaluate this integral, and then I will look at the limit as a approaches negative infinity. So you can try that one. And then the other split up is from 0 to infinity, 1 over 1 plus x squared dx. I'm going to split that as just like the last one as b goes to infinity, and now it's going to be from 0 to b, 1 over 1 plus x squared dx. All right, so I'll get you started on this. I know this is tangent inverse, so just holding on this for just a second. This, when I integrate it, use pink on that. When I integrate it, becomes tangent inverse, and I'm evaluating that right from a to 0. All right, so then that looks like tangent inverse of 0 minus tangent inverse at a. Well, I know tangent inverse at 0 is 0. So remember what that's asking. What angle measure gives me tangent of 0? So sine over cosine, I want where sine is 0, 0 over 1, that would be at 0 degrees or 0 radian. And so that's 0 we're talking radian. So 0 minus tangent inverse of A. Okay, so I'm really only looking at, since this is 0, it doesn't matter anymore. I'm really only looking at the limit as A approaches negative infinity of negative tangent inverse of A. Since this is 0, I don't have to worry about it anymore. So that's asking where is, what angle measure gives me where my limit will approach negative infinity. So where is that? And it actually, it's going to be, since I have two negatives here, it's actually going to be positive infinity, right? So where does that happen? It happens, let's see, let me think about this. Hold on just a second. Did I say that right? So when I plug negative infinity in, I'm looking for negative tangent. Actually, I want where, here's what that means. I'm just going to write it. Negative tangent theta equals negative infinity. So where does tangent theta approach negative infinity? So if I think about my graph, that should be at pi over 2. Yep. Yeah, at pi over 2.